Dr. Ravi Kanojia is holding the post of professor in Department of Pediatric Surgery at PGIMER Chandigarh. He is one of the youngest and finest pediatric surgeons in the country, especially in the field of pediatric minimally invasive surgery. He is my senior, my mentor, and was my proctor for my initial robotic surgery cases. He is always available for the juniors, phone call away. Currently, he is on leave from PGIMER Chandigarh and working as a consultant pediatric surgeon in Royal Children's Hospital, Muscat, Oman. Okay, over to you, boss.
Thank you, Intezar. Thank you so much. I would like to thank the organizers for giving me this opportunity to present this topic in front of the August meeting. And my great regards to Professor Kuril, Professor Bajpai, Dr. Rawat, Dr. Satyashri, and all the other seniors present in this meeting. It's an honor to present in front of all of you. So I'll need all your blessings and greetings to everybody who is present in the hall. So thank you so much once again for inviting me for this talk. So I will start my presentation. I'll share my screen. I hope my audio is clear and the slide is visible on your screen.
Yes, sir.
Okay, thank you so much. So 3D printing, when Intezar told me that if I can make some talk on some recent advances in pediatric surgery, I mean, recent advances is a very vague term, and it is very difficult to decide that what all things which are, which can be clearly said as something very new. So 3D printing is something which I've been involved with in the last 1.5 years since I've been here in Muscat. And I kind of self-taught myself this aspect of the new emerging technology. Although for the rest of the world, 3D printing is actually not new. It is almost a decade old, maybe a more than decade old technology which has been used in the commercial space for the non-medical uses and other places. Pediatric surgery is actually very late to this party of 3D printing and is actually seen as one of the recent advances in the field of pediatric surgery. So I decided, let us talk about 3D printing in pediatric surgery and what all are the potential applications of 3D printing. So within the current scope of the discussion today, I will just briefly touch upon that what is exactly is 3D printing and what are the specific uses that come out of 3D printing and the models that are made. What all hardware which is required for 3D printing and how is the entire process of 3D printing done, from start to finish. And then what are the potential applications that are being done in pediatric surgery, which can help us as pediatric surgeons to understand or, to teach the patient or teach the residents with the use of 3D printed models. So 3D printing, technically, the term is 3D printing is a layman's term. The more technical term is stereolithography. It was invented by a Japanese scientist, and it actually involves a photopolymerization of a particular material, which can either be a resin or a filament material, which when exposed to an ultraviolet light will convert into a solid mass. So this particular principle is used in 3D printing, where whatever layers that are created with the imaging software are hardened, and then one layer is built on top of the other, resulting in the formation of a 3D printing. It is technically called as an additive manufacturing, where you are creating three-dimensional objects which are there with intricate geometries from a digital file. Intricate geometries means whatever the model, either you're creating a model of a kidney or a model of a liver, where there are so many things all around it. So the geometry is very intricate. You cannot, build it from a mold or by hand. So it is best to make this kind of 3D model from a digital file of an actual patient or an actual subject. So this is the basic principle is that you have some material and then you add that material layer by layer and then make a 3D object so that there is a minimum amount of waste. This is exactly opposite to what a sculptor does while he is carving out a sculpture, where he starts with a solid block of stone and then sculpts a statue out of it, and which is called as subtractive manufacturing. And the material is cut away, and then there is a lot of waste which is happening, and it is entirely dependent on the ability and the skill of the sculptor who is making this statue. So 3D printing, for us to understand that it is an additive manufacturing process where just one layer is built on top of the other. So the real world use of 3D printing is mostly done for the rapid prototyping of commercial items. So whatever the car industries or the mechanical industries they are doing, whenever they are inventing a part of an automotive vehicle or some other manufacturing material, they will first make a prototype based on whatever the CAD drawings are there, so that they can see that what all are the problems in the prototype. Then only after making the prototype and finding all the flaws in the prototype, they will go on to develop the actual model with the actual material, rather than straight away printing with the actual material, which will be very expensive if they do that. Recently, you must have come across a news that there was in Bangalore, there was a post office which was built out as a 3D printed building. So what they did was that they took a large amount of resin material, put it in a software, designed a building, and then with large machines, they were able to print the walls and the rooms and the entire architecture into a building format, which they can use. So this is something which is used for, making buildings in a short span of time. Maybe if something is needed as a makeshift area, maybe as a camp or a refugee camp or a makeshift hospital, then those things will use the application of 3D printing. And this is being done very, very frequently now. In medicine, 3D printing is being done with many, many uses. I will come to the specific pediatric surgery uses in the subsequent slides. These are just some of the examples. So this is a hand, designed close to look like a Star Wars hand, which was done for a child, where his hand was amputated, and they designed a hand out of it. They made internal connections in a way so that he can move, he can have some fingers movement or the movement at the wrist, and the whole thing can act as a prosthetic. Similarly, in medicine, dentistry is one of the biggest customer of 3D printing, where because the bones are very easy to reconstruct and very easy to print, so that whatever defects which you have to reconstruct as a surgeon, you can first prototype it as a material with a 3D scan, and then make it patient specific with all the measurements, and then you can print that material. Similarly, in spine surgery, this is a 3D model of a lumbar kyphoscoliosis. You can see that you can study the anatomy very clearly, study all the angulations, and then you can do your treatment planning. Similarly, in maxillofacial surgery, this is an artificial jaw which has been created out of a 3D printed material, and it acts as a prosthesis. So initially, you make a prototype, and then you finally, once the prototype fits everything, satisfies your requirement, you can make it out of a titanium material which can be implanted into the body and replace a particular part. So how can 3D printing be used in pediatric surgery? So there are many usages. I have listed them on this slide. They can be patient-specific model. The printed items can be used for surgical planning and simulation, education and training. You can reconstruct the complex anomalies and the congenital conditions. You can, as I said, you can make customized implants and prosthetic. You can do minimally invasive surgery instruments. You can design all, and also you can have models designed for doing reconstruction inside. You can do simulations with the 3D printed material which is available to you, which will reduce the operating time and the anesthesia exposure. And obviously, whatever model that you have, you can actually use it to have enhanced communication, better counseling with the parents, where you actually show the anomaly to the patient, father or mother, in the form of a model, and then he is able to understand. Now, let us briefly touch upon the process of 3D printing. It is a bit technical, but once you get a hang of it, you will know how to do it. It starts as in three forms. It starts as a DICOM image. So imagine there is a patient of hydrourethronephrosis or a Wilms tumor or a duplex kidney, where you have some sort of imaging available with this patient. So it starts as a CT or MRI or for this patient, and there is a DICOM image which is available to you. So I will just start with how to start the 3D printing process when you have the DICOM images available. We'll touch upon the remaining two. When it is not a DICOM image, you just have some idea, or you want to scan some object, say chair or an instrument, and then modify it with the use of 3D printing. So DICOM to 3D prints. So you first start with a CT or an MRI scan. So there are softwares in between which convert the DICOM images into a printable file, which is called as the STL file. And this file is then fed into a 3D printer. I will show you in the subsequent slides. So first you obtain the DICOM images and then import into a slicer program. So this program which processes the DICOM images, is called as a 3D slicer, and which creates the 3D models inside the DICOM software and adds, all the slices of the DICOM images are added as layer by layer, and then a 3D model is constructed, and this is exported as an STL file, and then it is fed into the printing machine, and then it begins printing. We'll show you the actual process, and then there is some amount of post-processing which is involved. So 3D Slicer is the first software which you will require, and you will require some sort of learning. It's a freely available program. It's a full-featured version is available on the internet for a free download. And the software essentially marks the organ of interest in 3 layers, so that a 3D image can be made, and then it is exported in the STL file format. STL stands for stereolithography. So this is one of the screenshots of a 3D Slicer program where we have imported an abdominal CT scan, and you can see that the liver is marked and some of the organ of interests are marked. There is some sort of lesion over here, and then the software gives you a reconstruction. Then this particular reconstructed image is exported as a STL file, and it is put into the printer for printing. So then once you have the file from the 3D Slicer, there is second software. So there are total 2 softwares involved in the entire 3D printing process. First is the 3D Slicer, which helps you process the DICOM images. And once the DICOM images are converted into STL file, the STL files are fed into the 3D printing software. So this is one of the images which I reconstructed. It is a image of a hydroureteronephrosis, a VUJ obstruction. You can see that the dilated tortuous ureter is there, and the hydronephrosis bilaterally it is present. So this is something which you can actually, it has been extracted from those DICOM images by the 3D Slicer software and then fed into the software. This software is named as She2Box. It is also a freely available software available on internet. So none of these softwares you have to pay for. It is available free for download on the internet. So you can customize the size, shape, and the volume of the 3D printing model, and you can add or subtract any of the anatomical elements which may be. So if I don't want to print this femur bone, I find it is extra and does not contribute to the model, I can just delete this part and just keep the hydronephrosis part. So what it is doing is it is slicing the image that has been reconstructed. It will be hollow from inside. It is better to keep it hollow because otherwise the printing material that is required for printing the entire bulk would be very, very high. The resin is actually a very costly material. So there is another example. This is a horseshoe kidney which we made. And you can see that the model, this has been exported from the Slicer software, now coming into She2Box. And then you are trying to place it on the plate, get it ready for printing. So you can see that how you can have all the details of the complex anatomy of this region and the complex vasculature which is present over there. If you show this to a parent and try and explain them horseshoe kidney, it will be very, very easy for you. So again, this slicing is being done. The model is hollow from inside, and then it is ready for it to be put into the 3D printing machine for processing. So now your file is ready. You have done your thing in the slicing software, processed the DICOM, made the STL file. The STL file was put into the She2Box software, and now it is ready. So I took that image into a pen drive and fed into this machine. This is the machine which I have currently with me right now. It's a resin printer. Resin printer means that the initial ink that is used for making that model or the material starts off as a liquid resin. It's a polymer resin. There are other types of printers which are used where instead of a liquid, it uses a filament. And this sort of hub is there which will melt this filament and deposit it layer by layer on this plate and make the 3D model. Then this is the second machine which you will require, because once this model is made, it needs to be cured. Means it's a sort of a drying process where you shed off all the extra liquid that hangs onto the material. So this is the machine which I have. You can see that this is a tub where the liquid resin is there. This is quite an expensive material. This is the build plate to which the model will stick underneath this plate. And this is the console where the model has been fed. And once it has to be covered, because there is a 405 nanometer ultraviolet light which is thrown from below, which solidifies the resin material, and it should not be exposed to your eyes. So this is something which you have to keep away from the reach of children. So once the model has been fed, you can see this build plate will go and dip into the, it's going down and dipping into the liquid, and then gradually it will build up the model. It's sort of a hanging upside down kind of model. So I have started the process. This is a time lapse. It takes a very long time, almost 3 to 4 hours, depending upon the size of the printed model. You can see it is printing. You can see these are layers which you are seeing. With every layer, it exposes in a flash with the ultraviolet light from below and solidifies. And then the next layer is flashed, and all the layers keep sticking one by one on top of the other. So this is being printed. It is almost a 4-hour process which is squeezed, and gradually the plate keeps rising up as more and more layers are being printed. You can see the plate is coming up, and the model is it's slightly visible over here. The model is hanging upside down. So this is the model which has been built onto the plate. It will stick onto the plate, and this is what, once the plate is removed from the machine, this is what it looks like. You can see these support structures which are there, which are used to support the printing process. So this is that same horseshoe kidney which I printed last week. Now, once this model is printed, it is wet, filled with liquid, and you cannot touch this liquid. Actually, this is a very toxic liquid to skin. So be careful to wear your gloves and keep it away from the reach of children. So this is an ultraviolet curing station where the ultraviolet light is thrown onto this object. It takes around 5 to 10 minutes of this curing process, and all the liquid will be solidified, and all the material that has been used will become solid, and all the contact toxicity will be reduced to the minimum. So this is the final thing. You can see now we can remove the supports. So these are small supports which you can see, which are easy to peel off from your model. And once you remove all of them, you will be able to see the actual model. You have to be very, very careful to remove so that you don't cut the actual blood vessel or any other structure which you want to be there. So now you can see this model is ready. It's a horseshoe kidney model with the vertebra column and the aorta, the vessels which are seen. So this will be exactly like the patient must be having as an actual anatomy. So this is just an example to show that how 3D printing can replicate the actual anatomy. So initially, when I was learning myself by the help of YouTube videos, I just played around to learn the process of 3D printing. So before I went on to print all these models, anatomical models, I just printed some minifigures. Like this is the Star Wars Yoda minifigure. I printed, this is my son, this is my mother, this is another Star Wars figure. So I just scanned, with the iPhone camera, you can just scan a person and take a 360-degree video, and you feed it into the software. It will give you a 3D model which you can print. So this just helped me to learn the entire pre-processing, the software processing, and the post-processing, and to learn the printing process. Now let us come to the potential applications of whatever you can do with 3D printing. So once you know how to do the process, because most of the time, if you don't know, you will have to depend on a third party or another engineering collaborator or any other technical person to do all the process for you. But I always believe to do everything in-house. So as I said, this model can be used for education and training for your medical students, for your residents. At the same time, it can be used for communication with patients and families. And you can imagine that how easy it will be make you, if you're trying to explain a duplex kidney, if you're trying to explain a hydronephrosis, you can actually tell. And I'm sure in the near future, there will be a time when patients will come, they will have the imaging done, and the imaging services will provide a 3D printed model of their anatomy of a specific organ, and they will come with you, and you will be explaining them the anatomy on the model and all the procedures that you will be doing it. So that will be a different level of counseling for these patients. All the complex anomalies and the congenital conditions can be replicated into a 3D model. And you can see that there is a duplex kidney where you can see 2 ureters and the duplex system. Nowadays, even the antenatal ultrasounds, the 3D, 4D ultrasounds, which are being done in various centers, they actually offer you an image of the baby with a 3D printed model of your baby. So you can have the, what your baby would look like even before the baby is born. But the potential uses which I could see is that if there is a cleft plate, cleft lip, cleft palate deformity, limb deformity, or any other syndromic deformity which is there in the baby, can actually be very well seen and shown to the family that the child has got this. So this is some of the applications. There are a lot of prosthetic applications which are present in the literature. So this is one of the reports which I saw. This is a baby with a anotia, so no air, and many other congenital anomalies were present. So what they did is they scanned her other air which was normal, and then exactly created another air out of some silicon material which was made through 3D printing. So this is one of the potential uses. We see a lot of tumors, Wilms tumor or the liver tumors, solid visceral tumors in pediatric surgical practice. So this is a report where a bilateral Wilms tumor was studied. A 3D printed model was made, and then they actually virtually dissected also within the software and know that cutting where the blood vessel is going to come, or cutting where the vein is going to come, or callus is going to come. And they precisely sort of are guided by the 3D models which they were made. So this is the resected specimen. The yellow part is the tumor part which was 3D printed, and this is the full model of the kidney with the tumor. So you can imagine that if you're planning a nephron sparing surgery in these patients, how an actual model will give you a clear mental image to the surgeon, and he will be more confident while doing these surgeries. Liver and hepatobiliary planning. It's if you see this software reconstruction of liver tumors, they are amazing. They show you the anatomy in such a detailed manner that it is very difficult to see them on a CT axial images, on a CT plate, or on a DICOM system. So this is one of the models which I made with an MRCP image. I actually have it with me right now. If I don't know if you can see this. This is a MRCP model where you can see the gallbladder in the entire biliary tree which is there. So this is the picture for that material. So it's really amazing what all these software reconstructions can do. Pediatric genitourinary model can be created. We know that cloacal anomalies are very, very complex anomalies. So this 3D reconstruction was done using a MRI scan of a patient with cloaca, and then all the anatomy was replicated and reconstructed, and then later it was utilized for the surgical reconstruction that was done for these patients. Similarly, the same for the tumors which are there. The black areas represent the tumor. This is from another paper, and it was used for surgical planning. Pediatric cardiac models are very, very, you will find so many reports of pediatric cardiac congenital anomalies being guided by the 3D models and trying to understand the anatomy in relation to the actual anatomy which is present. And then they are replicated when the surgical correction is done for the cardiac complexities patients. So this is a model of a tetralogy of Fallet which is replicated, and then the surgical planning is done on the model itself. So it's a kind of a dry run of the actual process that you would be doing in the theater. So now this was about the DICOM images. So what you started with was a DICOM image, and then you processed it and then printed it and did the planning, or did the entire whatever the use case scenario that I described, you did that. Now, what if there is an instrument you want to design, it is there in their head. If suppose examine, I want to design a different kind of a Maryland forceps. So what can I use 3D printing for that? Yes, absolutely. So all these elements that you have, you first design in a computer-aided design. You can even make a handmade drawing on a piece of paper, scan it and feed it into a computer design software or the CAD software. One of them, the commonly used one, is called as the Autodesk. And it will convert that handmade drawing into a computer sketch. And then from there, you can just alter, modify, straighten the lines, and do the whole designing within that software, and then feed it into a 3D printer. So this is one of the instruments. These are the jaws of Maryland, where people are trying to do something different. And these are all the different materials: artery forceps, cannulas, laryngoscope, where the prototype is first made through the CAD software into a 3D printing. And then once they see and rectify all the flaws in that design, they will go on to make it commercially print with the actual material. So there are some of the other uses also of 3D printing where tissue engineering, where you provide scaffolds and then actual tissue is grown onto those scaffolds, and then there is drug bioprinting. I have not included within this part of the presentation because it is quite extensive and it is out of the expertise areas for me. So I've excluded that. But for the 3D printing process, I have tried to explain that how you do it. Although it is a technical process, but it is not hard to learn. All you have to learn and learn by playing around with the 3D slicer software and the She2Box software or something similar software, and then get the hardware to print that machine. The cost of that hardware machine is not very high these days. The cost has significantly come down. The ones which are commonly available can be purchased within, say, 50,000-60,000 rupees. And then additional some 5,000-6,000 rupees is used for is required for the raw material that you will need for the 3D printing. And it's something which provides a method of bringing your ideas to a prototype level. We get so many ideas while we are working with our patients, working with all the instruments that we have. Okay, this instrument should be modified in this way, this should be modified in this way. But to bring it out of your head and put it onto the computer and then making a prototype, 3D printing is the tool that you will require to do that. So once you have a prototype, you can refine it to make a clinically and a commercially viable design. And it's a valuable tool for replicating the abnormal and the normal anatomy for the clinical understanding. So 3D printing technology combined with tissue engineering, as I said, is the future direction of bioprinting in the field of pediatric surgery, because we have got so many defects and congenital anomalies which require building of a particular tissue over there. And if you are able to do that, you will be able to cure that condition. So that is one of the future direction and has got huge potential in terms of that. I feel that most of the institutions who are capable of doing so should have a 3D printing lab. It drives the innovation. You have now a lot of youngsters who are very comfortable with the software applications, and they have a lot of ideas. So if you provide them a base where they can execute their ideas, come up with the prototypes, and then do something out of it. The Western world is already doing it. Currently, our Indian scenario, we are lagging behind in this particular area. I certainly believe that this setup of this lab is not very, very expensive. Within 4 or 5 lakhs, you can set up this lab and allow your students, residents to come here and innovate. So I would certainly propose for that and would be one of my conclusions. So I hope I was able to give a short introduction on the field of 3D printing with its specific applications of pediatric surgery. And I hope it was interesting to the listening audience. Thank you so much. I would be very happy if there are any questions which Intezar can pass me on.
Thank you. It was a nice, mesmerizing talk. Any question?
Yeah.
Yeah. Dr. Kuril, I have one question.
Yes.
Yes, sir. You can come here, sir, please. You can show your face also.
Sir.
Yeah, hello. It was excellent to listen to your lecture.
Thank you, sir.
One question is that if we do high quality magnetic resonance imaging in female extrophy bladder of urogenital diaphragm,
yes,
then with the same technology, can we do 3D model of urogenital diaphragm in female extrophy bladder?
Yes, sir. It can absolutely be done. And if you take 3 mm
because after
slices,
listening to your lecture,
yes,
that's the first thing I'm going to try and going back to Lucknow.
yes, sir. Actually, I would like to tell the audience that when I was doing my thesis with Professor Kuril, we were actually making 3D models of the pelvic extrophy pelvis, bony pelvis, and we were studying all the features in that. So that was a part of my thesis. Probably that was the beginning point of learning all these things. So Dr. Kuril was well ahead of his time in doing these things. And to answer the question which sir had asked, yes, definitely it can be done. You just have to do a contrast enhanced 3 mm slice MRI scan and acquire the images and then feed it into the software. It is like a 1 hour job. Yeah, to print. You will get an exact
text
anatomy
of your lecture. I would like to that you send me the text of your lecture to my email.
Sure, sir. Sure.
Yeah.
Sure. Thank you so much, sir.
Thank you.
I also have one question.
Yes.
Yeah, boss, as you must be knowing that this all robotic surgery companies, they are working on virtual reality. What
Yes.
they are doing, they are trying to reconstruct the anatomy of the patient in the virtual reality. You will wear the VR handset and the anatomy of the patient will be in front of you in the virtual reality, and you can do the surgery, the patient in the virtual reality.
Yes.
So out of these two, your 3D printing and that virtual reality 3D reconstruction, and whatever you want to do, you can do in that virtual reality. Which one is better and why?
No, these it's not a question of which one is better over the other. These two things are entirely different. So the virtual reality software, now it's already available with the Symbionics company, the simulator which comes with the robot. It has got an operation of, say, hysterectomy, operation for appendicectomy, cholecystectomy, nephrectomy. Those operations are already fed into the system, and a particular trainee can go and do all the procedures within the simulator, and he will have the entire anatomy in front of him, which will be like actual in a real patient. 3D printing is something different. It is one step beyond the virtual reality system, where whatever the virtual reality models which are there within that system, you can actually print and have it in your hand and have a team discussion when you're dealing with very complex anomalies, say these extrophy with the where you have to reconstruct the pelvis and do osteotomies and all sorts of bladder reconstruction. There you can have the variable patient anatomy where you can print a patient specific model and do a treatment planning for that particular specific patient based on the model in front of you. So the whatever the virtual reality surgeries are there, if say there is a hysterectomy operation, it is a generic hysterectomy operation. It will not include the anatomical variations within that. 3D printing is something which you can customize to a particular patient. So these two are overlapping fields, but they are still different.
Okay. So any other? Yeah, boss. Yes. Doctor, yes. You can ask. I will repeat. You want to ask any question? Yes.
I just wanted to say hi, sir. This is Yasir here.
You can come here.
One question from your
Yeah, please let them come on the camera so that I can see. Or you can just turn. Hi, Yasir.
Hi, sir.
Hello, how are you?
So one question from your guide and now one question from your student. I have the iPhone nowadays.
Yes.
I can get the software which you said.
Yes.
Can you help me with the Chila box?
Yes, definitely.
Is
So
that
now
available here, sir?
all the iPhones and all the Google phones, it's a simple app. It's a free app with some limitations. It is better to take the paid app, which will cost you just barely like 500 rupees. And then all you do is you scan that whatever material or the object which you want to scan, and then process it into the Shitu box and then print a 3D material. That's what I did when I printed the sculpture of that Yoda, my mother and the son. I just scanned them and then printed.
So the Chila box is available in India, sir?
It is free of cost, available in the internet. You can just download whenever you want. It's free of cost.
Thank you, sir. Thank you, sir.
Hi, Dr. Ravi.
Hi, Dr. Sandeep.
So one question from Dr. Kuril Bab. Suppose I send my photograph to you, will you be able to print it in your institute?
Yes,
Your
I will
photograph.
be able to. I will be. But if you send me one
You have to
single
send a 3D
photograph,
video.
the resolution
Yes,
of that print would be little less. If I take a 360-degree photograph, the resolution will be like actual.
And what are the costs involved? What are the process involved? They do allow you to do all of these random things without any problem, because all of these are costly items.
Yes. So whatever I showed you, the machines, I own them. They are right now in the next room in my house. So the hospital
So
has
you have invested.
I have invested.
So you
I
have invested.
my own money around 50,000 rupees, and then the resin material is very expensive. It is 5,000 rupees for a 200 ml bottle. So that is the initiating cost, which will always be there. So I just invested as a hobby thing and did it.
So only 50,000 is the cost.
Yes, 50,000 is the roughly for an average printer. If you go for a hi-fi printer, then you will have to invest say 2 lakh rupees. But for an average printer, which is available on the Amazon very easily, you can buy it now if you want, and it costs you around 50,000 rupees.
And the resin will be around the 5,000 to 6,000.
Yeah, resin is 5,000 to 6,000 rupees. It is available on Amazon also.
Sir, to take a Dr. Kuril, we will ask sir to purchase one.
Then we can go to
Yeah, that's
December
why I
11th.
said, that's why I
Output of
said that
December.
for the
our
institute,
3D.
3D printing lab should be made because the cost is not very high. They already, if
But
you
we
have some
have
fund
3D
of 1 or 2
printing lab
lakh
here.
rupees, you can make it.
It is time consuming job, 4 hours for a print and then investment.
No,
Time
you
investment
don't
is
have,
there.
once you put the print into the machine, you don't have to sit in front of him. I put it usually in the night time, sleep, and in the morning the print is ready. It's just
you
the
need
process.
lots of motivation for doing this, na?
Yes, obviously you need to have interest in whatever you do. So then only you can do.
No, this resin is particular for particular printer, sir. It's any resin can be used in any printer.
No, there
Because
is
we have 3D printer here in AIIMS Rishikesh, but
Okay.
problem is resin is not there.
no resin. There
And
are
it's a costly printer.
So the resin is dependent on the wavelength of the ultraviolet light, which is inbuilt in your machine. So your machine will come with a list of resins which is compatible with that machine.
Okay.
So if it has got a 405 nanometer ultraviolet light, your bottle should show say that it is compatible with 405 nanometer light. There can be other resins which are used for, say, vehicle parts printing or some other big thing. Those will not be applicable to your printer. So your printer will come with a list of compatible resin material.
Okay.
Thank you.
Thank you, boss. It was a nice presentation. Come.
Thank you, sir, for your very insightful presentation on this novel topic. Sir, the memento will be received by Dr. Intezar Ahmed on your behalf, sir. I request Dr. Vijay Kumar Soman to give the hand over the memento.
I will virtually take it.
बस को दिखाई दे थोड़ा देर से दिखा दिखा इधर इधर बॉस
Thank you. Okay. Thank you once again. Regards to everybody there. And thank you for listening. So, Intezar, now I can close this room, huh?
Yes, boss. Thank you for joining.